Slopes of parallel and perpendicular lines. Slopes of parallel lines. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So we specify non-vertical because any two vertical lines will always be parallel. And we have to separate those because vertical lines have an undefined slope. So we can't say they have the same slope, but we can say that all vertical lines are parallel. So when we're talking about non-vertical lines, remember the key part is that they have to have the same slope. So when we look at these groups of lines below, they're all written in slope-intercept form, if possible, and all these sets of lines are parallel because they have the same slope. -1/2, -1/2, +1, +1. These two are vertical lines, so they both have an undefined slope and they are parallel. 2/3 and 2/3, +4, +4, +4, and then these are two horizontal lines that have a slope of 0 and they are parallel to each other as well. Slopes of perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So if you were to multiply the two slopes together, you should get an answer of -1. Another way to remember it is that the slope should be opposite reciprocals. Now, I want you to remember what that means. Opposite means that one of them needs to be positive and one of them needs to be negative. And reciprocal is where you flip the fraction. So if we have A over B, the second one needs to be B over A. So you just need to make sure both of these conditions are met, and then you can say that the two lines are perpendicular. Vertical and horizontal lines are always perpendicular. So again, if we look at these different groupings, you have a slope of +1/1 and a slope of -1/1. So since they're opposite reciprocals, those lines are perpendicular. +2/3 compared with -3/2. +3/2 compared with -2/3. +1/2 compared with -2/1. Vertical and horizontal lines, and then a -1/4 compared to a +4/1. So remember, perpendicular lines have slopes that are opposite reciprocals. Now let's work through a few examples. First, we want to find the slope of each line and determine whether they are parallel. So let's go ahead and look at this first example together. So first, let's find the slope of line AB. So pick any 2 points, and then we want to count rise over run. The rise is up 2 over 1, 2, 3, 4. So we have the slope of line AB is going to be up 2 over 4, which really reduces to 1/2. And then let's find the slope of line CD. This is up 2 over 1, 2, 3, 4. So again, the slope of CD, that line, is also 2 over 4, which is 1/2. Since both of the slopes are 1/2, that means that we can say that line AB is parallel to line CD. Let's go ahead and work the second one together as well. So again, let's look at line AB first, and then this one goes down 1, 2, 3, 4 over 2. So the slope of line AB was down 4 to the right 2, so that's a -2. And then let's look at the slope of line CD. This is down 1, 2, 3 over 2. So the slope of line CD is equal to -3 over 2. And that can't be simplified. So when you compare -3 over 2 to -2, those are not the same. So we would say that line AB is not parallel, so a slash through our parallel symbol, to line CD. I want you to go ahead and pause, try this third example, and check back with me when you're finished. Hopefully you found that the slope of line AB is 4 and the slope of line CD is also 4, so you can conclude that line AB is parallel to line CD. Now let's take the same idea, except this time we're going to talk about perpendicular lines. So we want to find the slope of each line. So first let's find the slope of this line. We'll just call it BD. Okay. So we go down 2 over 1, 2, 3, 4. So the slope of BD, that line, is going to be down 2 over 4, which is really simplified to -1/2. And then let's find the slope of line AC. So this is going to be up 1, 2, 3, 4 over 2. So slope of AC, that line is going to be up 4 over 2, sorry. And that simplifies to +2. So for perpendicular lines, we want to look for opposite reciprocal slopes. So double check that one of them is positive and one of them is negative, and that it's the fraction that's flipped. So 1 over 2, 2, and technically this has an imaginary over 1. So these are opposite reciprocals, so we can say that line BD is perpendicular to line AC. Let's walk through the second one together. So first let's find line BD, that slope. So we go up 1, 2, 3 over 1, 2, 3, 4, 5, 6. So the slope of line BD is up 3 over 6, which is +1/2. And then the slope of line AC is 1, 2, 3 over 2. So the slope of CA or AC, doesn't matter. This is really going to be -3 over 2. So if you compare the slopes, one is positive and one is negative. So the opposite part's fine. So we need to check the reciprocal. 1 over 2 is not the reciprocal of 3 over 2. This should really be 2 over 1, or this one should be 2 over 3. So since they're not opposite reciprocals, we would say that line BD, and we make our perpendicular symbol and put a slash through it. So line BD is not perpendicular to line CA. Go ahead and pause, try this third example, and check back with me when you're finished. Hopefully you found that line BD is perpendicular to line CA because BD has a slope of -3 over 3, which is really -1, and CA has a slope of +3 over 3, which is really +1. So I know it doesn't look like it here, but we definitely have one that's positive, one that's negative, and 3 over 3, the reciprocal is still 3 over 3. Here we just want to get into some practice of writing equations. So we want to write an equation of a line that has a y-intercept of +3, and first is parallel to this line, and second is perpendicular to this line. So let's take it one at a time, but we know that the y-intercept of +3 is going to be important for both problems. So for this first problem, whenever you see that it's parallel, that should alert you that we're talking about the same slope. So the slope that you see in this line, the +1/2, this is the slope that you want to have for the line that you're writing an equation of. Secondly, remember, we're given the fact that the y-intercept, which we use the letter B to represent, is equal to +3. Now, remember what we talked about last time, our Algebra 1 review of linear equations. When you're given the slope and the y-intercept, the easiest form you can write it in is slope-intercept form, which is y equals mx plus b. So we're just going to substitute the information we know, y equals mx plus b. And here is our final answer. Now in the second problem, where you see that it's asking for an equation of a line that's perpendicular to the given line, we definitely still want to work with that slope, but remember, if this is a slope, we want it to be the opposite reciprocal. So if this is positive, we know we want it to be negative, and then if it's 4 over 3, we want to flip that fraction 3 over 4. So this is going to be our new slope. And then again, we have a y-intercept of positive 3. So again, with slope and y-intercept, the easiest form to write it in is slope-intercept form. So we substitute in our values. Our slope is going to be negative 3 over 4, x plus 3 for the y-intercept. So remember, the only thing we're gathering from the equations we're given is the slope, because we're dealing with the perpendicular or the parallel and perpendicular aspect of it. Go ahead and follow the examples that we just did, and I want you to write an equation of a line that has a y-intercept of negative 4 and is parallel to this line and perpendicular to this one. Check back with me when you're finished. So again, remember that when we talk about the word parallel, it means same slope. So all you're taking is the slope from the line you're given. So the new line we're writing the equation of, the slope is going to be 4. And remember, we want a y-intercept of negative 4. So with the slope and y-intercept, substitute into slope-intercept form. So you should have gotten y equals 4x minus 4. For perpendicular, you want to think opposite reciprocal. So take the slope, that 1/2 becomes a slope of negative 2 over 1. And then the y-intercept, of course, is negative 4. So then with the slope and the y-intercept, we substitute into slope-intercept form and get y equals negative 2x minus 4. So now let's talk about writing the equation of a line that passes through a specific point and is parallel or perpendicular to a given line. So again, the only way that this differs from the examples that we just did is that instead of giving you the y-intercept, I'm giving you a specific point and saying the line you write the equation of has to go through point 5, negative 1. So let's pull out the same information. When it's parallel, it's going to be the same slope. And I know you can't really see anything there, but remember there's that invisible positive 1. And then we want it to go through the point 5, negative 1. Okay. So when you're given the slope and a point, the easiest form to write this in is point slope form. Y minus y1 equals m times x minus x1. So remember, slope goes in for m, the coordinate point goes in for x1, y1. So when we substitute in, we have y minus, our y1 is negative 1, and then our slope is 1, and then we have x minus our x1, which is 5. So remember, subtraction is in the formula, so it has to be there. And then if you have a negative coordinate, that negative also goes there. So we're just going to take one step in simplifying. Minus a negative becomes plus a positive. So we're going to change that. Now here, you do not need to distribute. However, because our slope is a positive 1, and multiplying anything by positive 1 doesn't change anything, for this problem, we're actually just going to remove the parentheses and write x minus 5. And this is our final answer. So let's walk through the steps again with the perpendicular line. So we're going to take that slope of negative 5/3, and we want to find the opposite reciprocal of it. And just to let you know, this right here is my squiggly arrow saying that we're going to take the opposite reciprocal. It's not some special symbol. So if our original slope is negative, opposite, we want ours to be positive. And reciprocal, if it's 5/3, we want it to be 3/5. And then of course we have the point, 5, negative 1. So again, since we're given the slope and a point, the easiest form to write our equation of a line in is point-slope form. So again, we'll substitute in the slope and the x and y coordinate of the point we're given. So we have y minus a negative 1 equals positive 3/5 times x minus 5. And again, the only thing we're going to simplify here is the y minus negative 1. Change that to y plus 1. And here, this was a very special slope when you get positive 1, but here, our slope is 3/5. So like I said before, we are not going to distribute that. You're actually just going to leave it like this. So the only thing you really need to simplify in point-slope form is when you end up with a negative x or y coordinate and you need to change that from a minus to a plus sign. Okay? So I want you to follow that example that we just talked about and then try these two on your own and check back with me when you're finished. So hopefully you remembered parallel lines have the same slope. Perpendicular lines have an opposite reciprocal slope from the one you're given. And then given the slope and a point, the easiest to use is point-slope form. And then when you substitute your information in, for the parallel line, you should have gotten y minus 3 equals 4 times x plus 2. And for the perpendicular line, y minus 3 equals negative 2 times x plus 2. That's it for this set of notes. I'll see you in class for more practice.